As the space industry rapidly expands, BIS certification has emerged as an undeniable essential. Join us on this cosmic journey towards ensuring quality and standards beyond our planet's boundaries. Welcome to MindSync, your compliance guard. I'm Baston Benny, and you're watching MindSync's BIS series. MindSync is a professional organization providing compliance, consulting, and advisory services. SSLV, which stands for Small Satellite Launch Vehicle, is an innovative space launch technology developed by ISRO and recently transferred to the private sector. SSLV is a small lift launch vehicle and it features a payload capacity of 500 kg for low Earth orbit or 300 kg for Sun-synchronous orbit, designed for efficient small satellite launches. Notably, SSLV is engineered with a focus on cost effectiveness, quick turnaround times, and minimal infrastructure requirements, offering launch-on-demand flexibility. As this technology undergoes privatization, the government has taken initiatives to standardize key aspects for quality and safety. In collaboration with ISRO, BIS has introduced 15 Indian standards. We have compiled these standards, and now we will dive into each one in detail. Our first standard is titled Space Systems, Program Management, Material, Mechanical Parts and Processes. This standard serves as the foundation for managing materials, mechanical parts, and processes within space projects. It covers every stage, from defining the mission to the eventual disposal of space assets. Key aspects covered by this standard include program management, documentation control, selection criteria and rules, as well as the evaluation, validation, and qualification of materials and processes. It applies to all space deliverable products across every program phase. Now, let's move on to our next standard, Program Management Part 2 Product Assurance. This standard is pivotal for ensuring the quality and reliability of space products. It sets out the policies and requirements for product assurance throughout the life cycle of space projects, from their initial definition to the production and operational phases. Under the umbrella of the standard, we find guidelines and principles governing product assurance management, quality assurance, safety assurance, and the assurance of materials and processes. Next in line is Space Systems, Safety Requirements Part 1 System Safety. Safety is of paramount importance in space endeavors, and the standard addresses exactly that. It defines the safety program and the technical safety requirements needed to adhere to safety policies across space projects. These safety measures encompass protecting product assurance management, flight and ground personnel, launch vehicles, payloads, ground support equipment, the general public, and preventing damage to public and private property. Let's now explore Space Systems, Electrical, Electronic, and Electromechanical Parts Part 1 Parts Management. This standard focuses on the management of electrical, electronic, and electromechanical parts within space systems. It provides critical guidelines for selecting, implementing, validating, and evaluating these parts, ensuring they meet the stringent requirements of space projects. Following that, we have Space Systems, Electrical, Electronic, and Electromechanical Parts Part 2 Control Program Requirements. In the standard, we find technical guidelines for developing and documenting control programs for AE parts. These programs guarantee that the parts used in space hardware are not only acceptable but also possess the necessary functional, radiation, and reliability characteristics to meet the overall system requirements. The standard also identifies management guidelines for space systems engineering activities and defines the minimum processes needed in this domain. Our journey continues with Space Systems, definition of the technology readiness levels, TRLs, and their criteria of assessment. TRLs are crucial in assessing the readiness of technology for space projects, and the standard defines them. It primarily applies to space system hardware, but these definitions can be employed in a broader context. These definitions are vital, as they set the conditions that must be met at each level, enabling precise TRL assessments during project development. Our next standard is Program Management, Requirements Management. This document plays a pivotal role in space program and project management. It deals with the management requirements for space projects and is applied through a top-down approach in the contractual relationship between customers and suppliers. The primary objective of the standard is to articulate and establish a common reference framework for all customers and suppliers within the space sector. It's designed to facilitate the deployment of requirements management practices across all space products and projects, ensuring consistency and effective management throughout the industry. Next standard is Functional and Technical Specification. This standard provides an overview of the respective purposes and positions of functional and technical specifications, their required contents, and the process for developing these documents. The standard is applicable to all types of space systems, all product elements, and projects. The objective of the standard is to state and establish a common reference framework for all the customers and suppliers in the space sector to deploy requirements management for all space products and projects. Now we arrive at space projects, program management, dependability assurance requirements. This standard specifies the requirements for a dependability assurance program for space projects. It extends to dependability requirements for space products and software-based system functions, ensuring reliability throughout all program phases. Next, IS Space Systems, Program Management, Nonconformance Control System. This standard specifies a robust control system for handling non-conformances related to any product within space systems. This includes electrical, electronic, and electromechanical components and software, as well as operational non-conformances and anomalies. This standard is applicable throughout various phases, including procurement, production, qualification, integration, test, acceptance, delivery, transportation, launch preparation, flight readiness, operational validation, operation, and refurbishment. Space Systems, Program Management, Quality Assurance Requirements. This standard defines the quality assurance requirements for the establishment and implementation of CAR programs for projects covering mission definition, design, development, production and operations of space systems, including disposal. Also, the requirements of the standard and its associated reference standards are tailored to the needs and classes of specific projects. Now we will look into space systems, program management, information and documentation management. This standard outlines the essential processes and requirements for effectively managing information and documentation within space programs and projects. These requirements affect both customers and suppliers at all levels and need to be adapted to align with the specific needs of each project context. Next, we have Space Systems, Program Management and Quality, Vocabulary. This standard provides definitions for common terms used in the realm of space systems and operations, particularly in the areas of program management and quality. While it offers clarity on common terminology, it doesn't include terms specific to individual international standards within space systems and operations, which are defined within those particular standards. Moving forward, we come to Space Systems, Program Management, Project Organization. This document outlines the principles and requirements governing project organization in space projects. It covers aspects such as the responsibility and authority of all actors, interrelations between actors, information technologies, and project organization documentation. Also, it is intended to be used as a basis when establishing and negotiating customer program, project management requirements and to guide the supplier's responses. Finally, we arrive at Space Systems, off-the-shelf item utilization. This standard lays out the requirements and guidelines for utilizing off-the-shelf items in space products or systems. It covers their selection, acquisition, integration, qualification, and implementation. However, it's important to note that the standard doesn't extend to piece parts and materials like electrical, electronic, and electromechanical parts, thermocouples, rivets, fasteners, connectors, fittings, adhesives, insulation, wiring, and plumbing. If your business requires certification and licensing under any BIS scheme, MindSync is here to assist. Let us take the lead in handling your certification needs, ensuring a smooth journey through compliance. Stay tuned for our next insight on the BIS series. Thank you.